Welcome back. Today we're going to be talking about combining like terms with rational expressions. Content objective is students will be able to simplify expressions, which is basically combining like terms involving rational numbers. If you're wondering what rational numbers are, those are going to include fractions as well as decimals. Language objective is students will be able to name the different parts of expressions. Why am I learning this? Well, it's important for solving multi-step equations for 7th grade as well as 8th grade. So, let's go ahead and jump straight into our very first example. Here we have some decimal coefficients. If you don't remember what a coefficient is, it's basically a number being multiplied by a variable. So -2 is a coefficient because it's multiplying by x. 3.9 is a coefficient because it's being multiplied by x as well. So the very first thing that I'm going to do before I start combining like terms is wherever I see subtraction, I'm going to add the opposite. So here we're going to add the opposite and add the opposite. Why did I do that there? Because they were subtraction. So now that I've done that, what I'm going to do is go ahead and combine all the x's first. I like to combine the coefficients first because you typically write the term with the variable first. So let's go ahead and combine this -2x combined with plus a -3 9/10. So I'm going to be a very big advocate on making sure that you show your side work off to the side. We don't want it to interfere in our work here with the flow of how we're showing our work. So please go to the side to do the work. So first I'm going to ask myself, are there more negatives? Are there more positives? There's definitely more negatives, okay? So I'm going to go ahead and mark that. It's going to be negative. Well, how many negatives do I have? I have 2 and 3.9. So 2 plus 3.9 is 5.9. Now, if you didn't know that, what you could do is just remember, okay, where is a decimal for a whole number? At the end. The same way a period ends at the end of a sentence. So 2 plus 3.9, if you add that, would have given you 5.9. So we have 5.9 negatives. We have 0 positives. So how many more negatives are there than positives? It's just 5.9. So I'm going to go ahead and put 5.9. And you need to be very careful. So a lot of students tend to forget the x. So be careful there. So at this point, what I'm going to do is then combine the constants. So quick reminder, we combined the x terms. Now we're going to go ahead and combine the constants. Constants are basically numbers by themselves. They're not being multiplied by a variable. So we're going to combine a +9 plus a -1 2/10. So I'm going to ask myself, are there more positives or are there more negatives? There's definitely more positives, so I'm going to go ahead and put plus. There are 9 positives and there are 1 2/10 negatives. Why did I write it like that? Well, because for a whole number, the decimal belongs at the end, the same way a period belongs at the end of a sentence. So how many more positives are there than negatives? Well, I'm going to have to find the difference between those two numbers. I'm going to get 10 minus 2 is 8. 8 minus 1 is 7. So we're going to get 7.8. So guess what? That's all there is to it. So a good tip to remember is make sure whenever you see subtraction, you add the opposite. Tip number 2, make sure you always ask yourself first, are there more negatives or are there more positives before you get to the actual side work? And of course, we know by this point, we need to practice doing side work. This way it doesn't disrupt everything underneath the actual expression that we're trying to simplify. Okay, now something that I forgot to mention is you need to understand this is equivalent to the original. They represent the same exact number, just one is a simplified version of the other, but they are definitely equivalent. It's important to understand that. Okay, so they look different, but they represent the same exact value. Okay, let's try another one. So same idea. What we're first going to do is check to see if there's any subtraction. If there is, we're going to go ahead and change it to addition problems by simply adding the opposite. So here, since it's subtraction, we're going to add the opposite. This one's already plus, so I'm not going to do anything to that. This one's subtraction, so I'm going to add the opposite. Now that I've done that, I'm going to go ahead and combine all the terms with variables. So here we're going to combine a 1.23w, and then we're going to combine a plus a -6w. So here I'm going to ask myself, are there more positives or are there more negatives? Well, there's 1.23 here and there's -6 here. So there's obviously more negatives. I'm going to mark it right away. I don't want to accidentally leave it off, so I'm going to put that. Now I'm going to go to my side work. So if it helps, just kind of separate your paper right away. That way you kind of define the space. So here, since there's more negatives, I'll write that number first. There are 6 negatives. Where does the decimal belong for a whole number? It belongs at the end, the same way period belongs at the end of a sentence. So here we're going to go ahead and line up the decimal 1.23, and that's positive. Notice I kind of left some space because I knew that I would need it here. So I'm going to go ahead and put some zeros here. How many more negatives are there than positives? Let's find the difference. This becomes a 10, this becomes a 9, and a 5. 10 minus 3 is 7. 9 minus 2 is 7. 5 minus 1 is 4. So we're going to go ahead and put 4.77W. We're not done yet. We need to go ahead and combine the constants together. Constants are basically, once again, just numbers by themselves. They're not being multiplied by a variable, unlike these. So I'm going to go ahead and combine a positive 19 with a, add that with a negative 2.5. So again, I'm going to ask myself, are there more positives or are there more negatives? Between 19 and 2.5, I'm going to definitely say there's more positives. So I'm going to put plus right away. Now off to the side, I'm going to go ahead and put there's 19 positives. Since there is no decimals, let's decide right now, where does it belong at the end? Just the same way a period belongs at the end of a sentence. I'm going to go ahead and put 2.5, making sure I line up the decimal. So those are negatives. How many positives are there than negatives? Well, I'm going to have to find the difference. So here we go. I'm going to have to borrow. 10 minus 5 is 5. 8 minus 2 is 6. 1 minus nothing is 1. Make sure you bring down that decimal. So we're going to go ahead and put 16.5. So once again, we need to understand this is, first of all, my simplified version. I can't simplify any further because this is a variable, this is a constant, so that's all you can do. And we need to understand that this is equivalent to the original. So again, this is equivalent to this. They look different, however, they do represent the same exact value. So that's a key word that we need to understand today, that they are equivalent. They look different, but they represent the same value. Okay, so now with that, let's talk about what if you thought maybe you should put plus a parentheses negative 16.5. I'm going to highly suggest that you don't do this, mainly because my open math doesn't like that. So please refrain from putting plus a negative. Simply just simplify that to either minus or negative. And one way you can think of it is this. Okay, imagine you're distributing a positive 1 to that negative. What is a positive times negative? It is a negative. So you could simplify it to just negative 77W minus 16.5, just like that. Okay, so now it's your turn. So why don't you go ahead and pause the video and try the next two on your own. Okay, so let's see how well we did. I'm going to go ahead and go over the answers. So for number 3, your answer should have been negative 10.7W plus 4.2. For number 4, the answer should have been 7.9C plus 25.8. Now, if you're not sure how I got these answers, you might want to go ahead and rewind and check numbers 1 and 2 again to see what I did there. So we're now going to go ahead and move on to the next problem. Okay, so for number 5, the last one we were working with decimal coefficients. Now we're working with fractional coefficients. So what we're going to do first is, again, look for subtraction. Wherever there's subtraction, we're going to add the opposite. So here, that's plus, leaving that alone. Here, subtraction, we're going to add the opposite. Here, it's already addition, so we're going to leave that alone. So now that I've done that, I like to first combine the terms with the variable. So I'm going to go ahead and combine a 5/9 x with, and I'm going to add that to a negative 1/3 x. So now I'm going to go off to the side to do my side work. Notice I'm going to define the space to do that. I'm going to go ahead and put 5/9 plus a negative 1/3. Notice I do put the negative up in the numerator. That way I can't lose sight that it is a negative. Another thing that I want you to notice is I am combining the terms with variables, but when I do the side work, notice I only look at the coefficient, aka just the number. Okay, so I leave off the x's in a sense. So now let's go ahead and combine these together. I like to first identify which one has a bigger denominator. 9 does. I'm going to ask myself, can 3 be multiplied to give me 9? The answer is yes. So let's go ahead and use 9 as our lowest common multiple. 9 times what is 9? Well, first of all, it's already 9, so it doesn't have to change, but you can think of it as, hey, we're multiplying it by 1. Now, is that really necessary? No. But just if you're wondering why, that is why. I'm going to go ahead and bring down the plus sign. Now, is a 3 and 9? The answer is no. So I could make it into 9 by simply multiplying by 3. So 3 times 3 gives me 9, so I'm going to have to multiply this by 3 as well. Notice it's a negative 1 times 3, so that's going to give me a negative 3. So here the denominator is going to remain a 9. I'm going to do 5 plus negative 3, so that's going to be a positive 2. So now we're left with 2/9 x, and now we have these two constants that we're going to go ahead and combine together. So now we're going to, notice I'm boxing it because I want to keep them different from the circle. So we're going to combine a positive 1/2 with a positive 1/4. That's going to be side work. Now, some of you do understand if I have a half and I have a quarter all together, I have 3/4. That's good. If you can't, that's okay. We can go ahead and do side work and show how that works. So we have 1/2 plus 1/4. The larger denominator is a 4, so ask myself, can 2 be multiplied to give me 4? The answer is yes. So let's go ahead and use it as our lowest common denominator. Is a 2 a 4? The answer is no, but we could make it into 4 simply by multiplying it by 2. So 2 times 2 is 4. Perfect. We're going to have to also multiply the numerator by 2, which gives us a 2. Now we're going to bring down the plus sign. Is a 4 a 4? Yes, so leave it alone. Now, since we're leaving it alone, we're going to leave the 1 alone as well. But again, if you're curious why that works, it's because you're technically multiplying by 1. So you got to multiply this by 1, and that's why it remains as a 1. So now we're going to go ahead and keep the 4 as a denominator. Simply add 2 plus 1, which gives us 3. So once again, you see that we do have 3/4. Now, some students might do this, which is a little confusing because at first glance, it kind of looks like 2/9 times 3/4. So you need to understand when it is positive, you need to put plus. Now, if it's negative, you can kind of think of it as minus. So now this is our simplified version. Notice I can't combine it any further. So I'm going to go ahead and consider this equivalent to the original. Okay, but this is my final answer. And again, the key word is the fact that these two expressions are equivalent. They look different, but they represent the same value. So what if your answer is 3 2/9 x plus 1 3/4? Okay, please let's start practicing writing them as improper fractions. Okay, that's going to save us a lot of time, so keep that in mind. Okay, moving on to number 6. So I'm just going to go ahead and do one more example before I have you try some on your own. Okay, so same idea. We're going to first combine the variables together. So we're going to combine a 9/11 w with a positive 1/2 w. But wait, I almost forgot something very important. Whenever we see subtraction, we need to practice adding the opposite. So this one was fine because it was plus. This is also fine because it's a plus. But this here is a subtraction. Let's go ahead and add the opposite. Okay, now that I've done that, I can go ahead and move on to some side work. Let's go ahead and do 9/11 plus 1/2. Now I'm going to ask myself which one's the greater denominator. Is 11 Can 2 be multiplied into 11? No, so I'm going to go to the next multiple of 11, which is going to be 22. Can 2 be multiplied to give me 22? The answer is yes. So let's go ahead and use 22 as our lowest common multiple. Is 11 a 22? The answer is no, but I could make it into a 22 simply by multiplying it by 2. 11 times 2 is 22. Perfect. So we're going to go ahead and multiply the numerator by 2 as well. 9 times 2 is 18. Let's bring down that plus sign. Now, is a 2 a 22? The answer is no, but we could make it into 22 simple by multiplying it by 11. So 2 times 11 is 22. We're going to multiply the numerator by 11 as well. So 1 times 11 is 11. So now that I have that, the 22 is going to remain the denominator. So we're going to do 18 plus 11, which is going to give us 29. So notice this is typically where you would kind of turn this into a mixed number. I'm going to tell you, stop right here. Don't waste your time. Go ahead and leave it improper. So we're going to go ahead and write it as 29 over 22W. This is okay. Okay, I know this is not what you're used to, but from now on, we're going to leave our fractions improper. So now we're going to go ahead and combine the constants. So we're going to combine a 3/4, positive 3/4, and combine that with a negative 1/2. Sorry, negative 1/5. So I'm going to do some side work. I'm going to go ahead and write 3/4 plus a negative. Notice I put the negative in the numerator so I don't lose it. Now let's go ahead and combine them. 5 is the greater denominator. Can 4 be multiplied to give me 5? Nope. Okay, so I'm going to keep track. The next multiple is going to be at 10. Can 4 be multiplied to give me 10? Nope. Next multiple is 15. Can 4 be multiplied to give me 15? Nope. Next one is 20. Can 4 be multiplied to give me 20? Yes. So let's go ahead and use 20 as our lowest common multiple. Is a 4 or 20? The answer is no. But I could make it into 20 simply by multiplying it by a 5. So now 4 times 5 is 20. Perfect. So 3 times 5 is now 15. I'm going to go ahead and still add. But the next is 5 to 20. The answer is no, but I could make it simply by multiplying it by 4. So multiply the numerator by 4. So here 5 times 4 is 20. Perfect. Negative 1 times 4. This is a spot where a lot of students make errors. A lot of students count that as a positive one, and they end up putting 4 here, which kind of throws off their answer. So it's really important that you understand that is a negative. So you need to count it as a negative 1 times 4 is a negative 4. So our denominator is going to remain a 20. And then here, our numerator is going to be 15 plus negative 4. There's definitely more positives. How many more positives are there? Well, there are 11 more positives. So again, you don't want to just put 11 over 20. Since it's positive, we're just going to put plus 11/20. So that is our final answer. And hopefully you remember from the previous problems that we understand that this is equivalent to the original expression. They look different, but they represent the same exact expression. Okay, so now why don't you pause the video and try number 7 by yourself? Okay, so for number 7, I'm actually going to go ahead and go over it so that you can see how it would be done. 7 is a little bit different because you're going to find yourself combining 3 different fractions together. So I want to show you how that would work. Okay, so first of all, let's combine the variables. Wait, before we do that, let's go ahead and add the opposite for all the subtraction that we see. This is addition. We don't need to change it. This is addition. Don't need to change it. This is subtraction. We need to add the opposite. This is already addition, so leave it alone. So now that I've done that, let's go ahead and combine the variables together. We have a negative 1/4 W and a positive 2/3 W. Notice I always include the sign in front. That kind of tells me if it's plus or minus. So with that, I'm going to go ahead and define my space for some side work. I have a negative 1/4. So again, you'll notice I put the negative up in the numerator to kind of remind me, hey, it's negative. I don't want to lose sight of that because it's something a lot of students tend to do. So I'm going to go ahead and add 2/3 here. 4 is the greater denominator. Can 3 be multiplied to give me 4? Nope. The next multiple is 8. Can 3 be multiplied to give me 8? Nope. Next multiple is 12. Can 3 be multiplied to give me 12? Yes. So 12 is our lowest common multiple. So 4, is that a 12? The answer is no. So I'm going to make it into a 12 by multiplying by 3. So I'm going to multiply this by 3 as well. Again, notice it's a -1 times 3. Not just 1, a -1. So -1 times 3 is -3. Now, you're going to notice I always write the work off to the right for this reason. Some students put times 3 like this, which to me looks a little confusing because it looks like times 3 minus 1, which I don't really like. So that's why I do squeeze it here. I know it kind of runs into the operation, but to me it makes more sense. Okay, so now I'm going to go ahead and bring down the plus sign. Is 3 a 12? Nope, but I could by multiplying it by 4. So I'm going to multiply this by 4 as well. So it's 2 times 4, which is 8. 12 is going to remain the denominator. So here, -3 plus 8, there are more positives. How many more positives are there? Well, there's 5. So this is going to be a positive 5/12 W. Now I'm going to go ahead and combine the constants together. That's going to be a plus 3/5 plus -1/4 plus 1/5. You could do this step by step and combine 2 and then combine the last one on its own, but I'm going to show you that we could do all of it all at once. So let's do 3/5 plus a -1/4. Again, put that negative up in the numerator so it doesn't get lost, plus 1/5. So you'll see here the 5s are definitely the larger denominator, so we're going to go by multiples of 5. Can 4 be multiplied to give me 5? Nope. Next multiple is 10. Can 4 be multiplied to give us 10? Nope. Next one's 15. Can 4 be multiplied to give me 15? Nope. Next one's 20. Can 4 be multiplied to give us 20? The answer is yes. So 20 is going to be our lowest common multiple, so we're going to put 20 here, 20 here, and 20 here, since there's 3 separate fractions. So is 5 a 20? No. So we're going to transform it by multiplying it by 4. So 3 times 4 is 12. And now I'm going to bring down this plus. Same idea here. Is 4 20? Nope. But I could make it into 20 by multiplying it by 5. So here, notice it's a -1 times 5. So that's going to be a -5. Bring down the plus sign. Now is 5 a 20? The answer is no. So I'm going to multiply it by 4. 1 times 4 is 4. So now our denominator is going to remain a 20. So now here, let's go ahead and think to ourselves, are there more positives or are there more negatives? Hopefully you can see there are more positives. How many positives are there? Well, I'm going to do an extra side work. I see there's 16 positives. How many negatives are there? 5 negatives. So how many more positives are there than negatives? Well, there is 11 of them. So I'm going to go ahead and put plus 11/20. So notice here you didn't have to add them separately. For example, you didn't have to add 3/5 and 1/5 and then do 2/3. I mean, you could have since they are already like denominators, but you can also just combine them like this as well. Okay? And almost forgot to mention that this is equivalent to the first expression. They look different, but they represent the same exact expression. Okay, so now look at number 8. We're going to simplify this by combining like terms. So I'm just going to show you the steps real quick. A lot of you might feel more comfortable turning all fractions to decimal because you think working with decimals is easier. Notice I said think. Sometimes it is easier, I'll admit that, but in certain cases, working with decimals all the time can be a little messy. Let me show you. So for example, if I convert minus 1/3 into a decimal, you're going to end up with 0.3 repeating on the 3. 2/3 turned into a decimal is going to be 0.6 repeating on the 6. So if you combine these two variables together, these two terms, you're going to end up with 0.06 repeating on the 6. And that's not accurate because it's a repeating digit. So it's basically messy here. It's going to be hard to make sense of it right now. Now, if you convert these decimals into fractions, like this is 4/10, which reduces to 2/5, and this is 2/10, which reduces to 1/5, then you can handle this. This is just like the previous examples before. With more practice, you're going to get really good at fractions, and converting things, and working with fractions isn't going to be such a daunting task. So practice makes perfect, so keep that in mind. When you do have both decimals and fractions, converting it to fraction might be your best bet. Unless you see the numbers don't repeat and it does work out nicely, then that's totally fine to keep them as decimals. So here I can just simplify them by combining these two terms together, leaving me with 1/15 f plus, in this case, 5/17. It's doable, it's exact, and it's not estimating with decimals here. Okay, so for number 9, if you follow my instructions, you're going to remember that it's going to be best to convert decimals to fractions and just simply work with fractions. So here, this I would read as -7/10. So I'm going to go ahead and rewrite that as a -7/10 m plus 5/7 plus 5/2 m minus here. I would read this as 25/100. Notice I'm not writing it here because I know 25/100 can be reduced. In fact, it could be reduced by 25. When I reduce it by 25, I am going to end up with 1/4. So this is now a 1/4. Now, here's the thing. If you are able to read that as 25/100, but you left it like that, you are going to have to deal with slightly larger numbers, which I don't suggest you do. Always reduce whenever possible. It makes life much easier, I promise. So now this looks like a previous example that I've done in the past. So I'm just going to go ahead and do the same thing. I'm going to check to see if there's any subtraction. In this case, there is, so we're going to add the opposite. Now I'm going to combine like terms, so I'm going to combine the variables together. Notice I'm going to circle the sign in front, even if it's a plus. A lot of students like to leave it off when it's a plus, and then they get into the habit of it, and then when it's subtraction, they still leave it off. So here we have -7/10 m plus 5/2. So again, I can't stress this enough. Always keep the negative up in the numerator, that way it doesn't get lost. 10 is my greater denominator, and guess what? 2 can be multiplied to give me 10, so 10 is my least common multiple. Okay, is a 10 a 10? Yes. So is this -7 going to change? Nope. We're going to bring down the plus. Is a 2 a 10? The answer is no. So let's change that by multiplying it by 5. 2 times 5 is 10. Let's multiply this by 5 as well. So 5 times 5 is 25. So the denominator is going to remain a 10. Are there more positives or negatives? Definitely going with positives. How many more positives are there? Well, there's 18. Now remember I told you that you could leave it improper, so let's do that. However, I do notice that this can be reduced, so let's reduce that by 2 since they are both even. So we're going to go ahead and reduce that to 9/5. So it is positive because, again, we notice there's more positives than negatives, so I'm going to put 9/5. But again, please don't forget, this is something that some students do, is they forget the variable. So make sure it's still there. Next, what we're going to do is combine the constants together. 5/7 plus a -1/4. 7 is the greater denominator, so can 4 be multiplied to give us 7? Nope. This next one's going to be, can 4 be multiplied to give us 14? Still no. Next one's a 21. Can 4 be multiplied to give us 21? Nope. Next number is 28. Can 4 be multiplied to give us 28? Yes, so 28 is our lowest common multiple. Is a 7 a 28? The answer is no, so let's go ahead and multiply that by a 4 to make that happen. So 5 times 4 is 20. Bring down the plus sign is a 4/28. Also a no. So we're going to multiply that by 7. That means the numerator is going to be multiplied by 7. Notice it is a negative 1 times 7. What's negative 1 times 7? Negative 7. So here the denominator is going to remain in 28. Are there more positives or are there more negatives? There's definitely more positives. How many more positives are there? 13. So because there's more positives, we're going to go ahead and say it's plus 13 over 28. And there you have it. Let's not forget that this here is equivalent to the first expression here. They do look different, but they do represent the same exact expression. Now it's your turn, but before you get started, I want to talk about something here. So for number 10, you need to understand, first of all, that we are going to turn all subtraction to adding the opposite. So adding the opposite. Now here, it's not necessarily subtraction, where you can interpret it different ways. You can consider it as subtraction, or you consider it as multiplying it by a negative 1. So you're kind of distributing that here. So either way, you're going to get the same answer. It is going to turn it into a plus, okay, because we're adding the opposites, or you can say a negative times a negative is a positive. So you can connect that with what we were practicing with distributive property. So go ahead and pause the video and try this one by yourself. Okay, so the answer is negative 1/50 x plus 4/5. Hopefully you converted these into fractions and you're able to figure it out from there. Just FYI, this would have been 1 1/10. And if you convert that into an improper fraction, that should have been 11/10. And this one here should have been 22/100. If you reduce it, you should have gotten 11/50. Okay, and with that said, let's go ahead and move on to the very last one. Number 11, which of these expressions below are equivalent? So again, equivalent means they represent the same exact value. The only thing is they look different. So what you'd have to do is simplify each and every expression to see if it does equal this. Now, you need to keep in mind, you need to understand what 3/8 is as a decimal, what 2 and 7/7500 looks like as a fraction. That way you can best compare the numbers. So with that said, here are the answers. The answer is going to be B and C. Guess what? That is going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.